Hi everyone, in this video I'll be going over Apply Your Learning question number 2 from the Net Ionic and Acid-Base Equations unit. Question number 2 asks, what is the final net ionic equation when hydroiodic acid is reacted with lithium hydroxide? Looking at our table, we can identify hydroiodic acid as Hi, and lithium hydroxide is in the group 1 hydroxide section, and it is denoted as LiOH. So here I have pasted a clip of the steps for writing a net ionic equation from the lesson. And we'll start with step number 1, which is just writing the chemical equation, including the state of each compound. So since it's an acid-base equation, we know that there's going to be an acid combined with the base, and that will result in water and a salt. So our acid is Hi, and since it's a strong acid, that'll be in the aqueous form. Our base is lithium hydroxide, which is also a strong base, which will be in the aqueous form. It'll react to form water, which is just by default in liquid form. And then when we take out the components of water, we see that the resulting salt is Li, or lithium iodide. And we can check our general solubility rules. Lithium is a group 1 ion, and we can see that compounds of group 1 ions are soluble ionic compounds. So this will also be in the aqueous form. So step 1 is complete. Let's move on to step number 2. In step number 2, we need to expand the chemical equation, rewriting all aqueous compounds as their constituent ions. And you can refer to the periodic table to see what charge each ion would have, but I'll go ahead and write them here. Hydrogen will have a +1 charge. Iodine will have a -1 charge. Lithium is +1. OH is -1. Then water is just water because it's not in the aqueous state, so we leave it as is. And then lithium iodide will break up again into Li plus and I minus. So that's step number 2. Step number 3 we'll do in the same line. And that is to identify the spectator ions and eliminate them from the equation. Remember that spectator ions are ions that remain the same from start to finish. They don't change forms, and they'll remain aqueous on both sides of the arrow. And so looking on the right side, I can see that the only ions remaining are Li plus and I minus, and they're present as ions at the beginning as well. So those are our spectator ions. We can go ahead and eliminate them from our net ionic equation to make our net ionic equation. Next is step number 4. And we just simply rewrite the equation with only the participating ions and compounds. So we write whatever's left over. So we have H plus OH minus, and that results in H2O in the liquid form. And this is our net ionic equation. So this is the answer to number 2. And just as a little tip for future questions, this is also the net ionic equation for other common acid-base reactions. So since an acid combined with the base will give water and a salt, as a general rule, the net ionic equation will end up being the same, since the acid will be aqueous, the base will be aqueous, and the salt will be aqueous, and water is the only thing that is changing from start to finish. Everything else will be spectator ions, and so this right here is a good general equation to know. It is the net ionic equation for acid-base reactions.